चलिए दोस्तों शुरू करते हैं विदाउट वेस्टिंग ए टाइम. Today we have this lab and this lab is regarding the route reflected loop for the IP based forwarding, or we can say forwarding loop. So how the forwarding happens, let's see. This is the topology we have, and this is the CE device, and these are the two PE device. This CE device is the dual home, is connected with the two PE device, PE1 and PE2, and these are the two route reflector we have, and route reflector 1 and route reflector 2. And this P1 is the client of RR2. So for this P1 route reflector is RR2, and similar way for this P2 route reflector is RR1. So how the forwarding will happening here is, let's suppose this is the prefix we have an 11.11.11.11, which is the part of BGP AS2. From this C advertised to this P and this P. Okay. Once this prefix will reach on the PE, and PE will further advertise this prefix to the, as this PE is the client of this RR. So this P what will do? This will advertise this prefix to this RR2, and similar way this P also will receive the prefix from the C. So this will advertise this 11.11.11 prefix to this RR. Once this, so here I get the output of show route of the custom prefix, which is 11.11.11. From all the four routers, put the output here. Okay, let's see here. So let's first check here. In this is the P1 router. Here we are checking the show route 11.11.11, and we are getting this route from 199.168.1.1. This is the interface IP of this C1. Okay. Now what happening is, this P1 is the client of RR2. So this P1 will advertise this route to this RR2. Okay. Now we are checking on the RR2. We are checking show route 11.11.11. This is telling this route is coming from 22222. 222 is the IP address of PE1. Similar way, C and advertise this route to the PE2 also. Here we check the route, show route is telling this route is coming from 198.168.1.1. This is the interface IP of this CE1. Okay. Now this PE2 is the client of RR1. This PE2 will advertise this route to their route reflector. So now we are checking here also, show route 11.11.11. So it's showing this route is coming from 44444. 4444 is the loopback address of PE2. So now how the loop will occur? Let's check this output here. Let's trace this destination 11.11 from this RR1. Okay. Show route 11.11 is telling this route is coming from the 4.4. So what we will do? We will check the route, show IP route 4.4.4, from where it's coming. So we'll find this route is coming from this interface via RR2. Okay. We reach on the RR2. On the RR2, what we'll do? We will do again check the route for the destination. Our destination is 11.11.11. We are again checking the route 11.11. What is telling this route is coming from 222. Okay. We will again check the route for the next stop. 222 will check that route will be coming from the ISS. From where it will come? It will come from the RR1, because 2.2.2 is the here. Again same way on this RR1 will come. Again we'll check the route. Show route for the destination prefix is 11.11. This is telling this is the next stop. Again we'll check the route for the next stop. Once we check the route for the next stop, that we again will come from the ISS. From where it will come? It will come from RR2, because here is the PE2 loopback 4.4 is connected. So this is the ways loop is happening. Let's jump to the router. Let me see actually output also. Let me do the trace route also to show how this loop is happening. Let's check the route for our customer prefix, that is 11.11.11.11 is coming from 444. We check the route for this next stop 4.4.4.4, telling this coming from the gigabit ethernet 0/0. Let's do the show ISS neighbor. So this gigabit ethernet 0 is the PE1 route. Right? And the gigabit, sorry, this is the RR2 route. Okay. Let's do the trace route for this 11.11.11.11. This is loop we have. You see the IP address 194.168 is going to 1.2, then 1.1, 1.2, 1.1. is the IP address of gigabit 10/0/1, and this is connected to RR2. Okay, so this is how loop is happening between this RR1 to RR2. Let's do same check on the RR2 also. Let's check the customer fix route, that is 11.11.11.11. Let's check the route for next hop, that is 2.2.2.2, and let's do the trace route 11.11.11. Again, here also loop is happening. Again, the same interfaces which we have seen on the RR1 also. Seen that how the loop is happening while we are doing the trace route to the customer prefix 11.11.11.11 from route reflector 1 and route reflector 2. So what is the solution? That in case of BGP RR, logical topology should follow the physical topology in case of IP based forwarding. We will not face the similar issue or same loop issue in the case of MPLS based forwarding, where the forwarding happening on the label basis, not on the IP basis. So to solve this issue, for this PE1 should become the client of this RR1, and similar way this PE2 should become the client of RR2. So we have to follow this physical path in case of IP based forwarding.